In this example, we want to write a rule for the given sequences, and we've got a couple to work with here. The first one is 3, 5, 7, 9, comma, dot, dot, dot. That means that this sequence continues to infinity. A sub 1 is math shorthand for the value of the first term, and the value of the first term is 3. It's whatever number appears first. The common difference is actually what we're adding each time. How would we go from 3 to 5, from 5 to 7, from 7 to 9? In this case, we're adding 2, so the common difference is plus 2. That one's relatively easy. If you are having a tough time figuring out what that common difference is, all you need to do is take one term, let's say the fourth term, and subtract the third term, or the one previous to it. So we would take 9 minus 7 and get 2. 7 minus 5 is 2. 5 minus 3 is also 2. Kind of a nice way to do that if you're having a tough time finding what that common difference is. The rule, I'm going to do a little work down here. I'm going to write a formula down for you. For an arithmetic sequence, we can take the value of the first term, add d times n minus 1, and we'll arrive at that formula. There's another way to do it. I'll show you the connection here in a second. But let's just use this formula and plug in some values. So we've got a 3 for a sub 1. D is 2, and we're not going to know. This is a rule or a formula, and so we're going to have that as a variable. What this formula will do for us, though, is it'll allow us very easily to find the value of a term if we know its position. So we'll have a sub n is equal to 3. I'm going to use the distributive property here to kind of clean this up a little bit. So 2 times n is 2n, 2 times negative 1 is negative 2. I'm going to rearrange my terms and combine like terms, so I like to write the term with the variable first. And then 3 minus 2 would be positive 1. So this is really the rule here. A sub n is equal to 2n plus 1. To see how this works, you can pick any term that you know, like let's say the third term right here, and you just plug in 3 for n, and you should get whatever the third term is out of it. So it's 2 times 3, which is 6, plus 1, which is totally 7. If your rule does not accurately describe every single term in the sequence, then you need to make an adjustment. Also, notice that if you went back 1, so if there was n is equal to 0, the 0th term would be this just previous to the first one, right? Well, the common difference here is 2, and we can reason that that should be a 1. 1, 3, 5, 7, 9, etc. Well, that's like the y-intercept in slope-intercept form, and so that's where you see that plus 1 at. When n is 0, we have a plus 1. That actually is not part of the sequence. The sequence starts with 3. But to be able to write the formula, it's nice to be able to reason through what that prior term would have been, or would be. Also notice that d is the constant rate that this is going up by. It's going up by 2 every time. And so that's really a slope right here. When we see the coefficient here of n, that will be the common difference or the slope if you're using slope-intercept form. So there's a few different ways you can work with this. The formula is nice to use, but you can do a little bit of reasoning as well and make some connections between some prior topics. Let's work with the second one here. We've got 2, 6, 10, 14. I know the value of the first term. It's just the first one that's there. It's 2. The common difference here, I think it's going up by 4 every time. You can verify by taking one term and subtracting the previous term, like 14 minus 10 is 4. 10 minus 6 is 4. 6 minus 2 is 4. So we know the common difference is positive 4. You could have a negative value here if the numbers were in descending order and you subtracted the same thing. You really want to think about what you're adding each time, and you could be adding a negative, but that's not the case with this one. The rule then, if we work with this a little bit, again, a few different ways to think about it. Let's use the formula here. And the first term is 2. We've got d being 4. And then we'll just do the distributive property here. So we've got 2 plus 4n minus 4. And we'll put the 4n first. 2 minus 4 is negative 2. At first glance, you might think, well, what the heck's a negative number doing there? These numbers aren't negative and you're just increasing. Well, if you look at the second term, maybe, n is 2 for the second term, so we would do 4 times 2, which is 8, minus 2 is 6. So if you know the term position, like the first, second, third, fourth, etc., all you need to do to find the value of that term is substitute it in for n. And this formula does accurately describe every single term in that sequence, 4n minus 2. Now again, let's link this back to slope-intercept form. So if we backed up 1, the position that would be here would have to be negative 2. If we went backwards, we would be subtracting 4 each time. And so 2 minus 4 is negative 2. So there's your y-intercept. And the rate is 4. We're going up by 4 each time, so that'll be our slope.